Hello? Hello, Ashwati. Mic ശരിയാക്കണം തോന്നുന്നു.
Hello?
Yes. Yeah.
Hello?
Yeah, think it is better.
Oh, yeah. Hello?
Yeah, good. Okay. Let's see. Hello, Pradeep. You're muted, I think.
Hi, Shajesh. How are you doing?
Yeah, doing good, doing good. Yeah, nice to see you again. Cool.
Yeah, my daughter will not be able to join. She's gone for her classes, actually.
That's okay. That's okay. Yeah, yeah. This might be a little too simple, maybe like just phases of moon. I just wanted to do something on astronomy.
Okay, good.
For 8th grade students. So
yeah.
So okay.
Great.
Yeah. So Adish, do you know if others are joining?
I don't know.
You don't know.
എന്നാ മനസ്സിലായ വായിക്കട്ടെ ഇവിടെയല്ല.
Okay, I was planning to just have a discussion today on phases of moon, but the usual students who come are not here. So we'll see how it goes. Is it okay, Adish and Aryan and Joanne, if I ask some questions and you guys participate in it? So have you guys looked into the sky in the night?
Yeah.
What do you see?
Stars, moon, and other planets.
Is there any pattern in it?
Yes.
Like?
3 stars.
Yes, that's also a pattern. I was thinking more like the
Orion.
sun. Does the sun rise and set? Is that right? The sun rises in a certain direction and sets in a certain direction, correct?
Yeah.
In what direction does the sun rise?
West.
East.
East.
Yeah, sun rises in the east direction. And then what does it do if you follow the pattern? Have you ever followed the sun?
Sir, മനസ്സിലായില്ല ഒന്നും കൂടെ പറയാം.
സണ്ണ് സ്കൈയിൽ നോക്കിയാൽ ഒരു ദിവസം നോക്കിയാൽ എന്താണ് ചെയ്യുക? ഒരു
നമ്മള് എർത്ത് റൊട്ടേറ്റ് ചെയ്യുന്നതനുസരിച്ചിട്ട് ഇങ്ങനെ ഡേ നൈറ്റ് സർക്കിൾ ആയിട്ടാവും.
അല്ല, പക്ഷേങ്കില് അത് ശരി തന്നെ. പക്ഷേങ്കിൽ ഇപ്പൊ സ്കൈയിൽ നോക്കിയാൽ സൺ എങ്ങനെ ഉണ്ടാവും? സണ്ണ് ഒരേ സ്ഥലത്തായിരിക്കോ അല്ലെങ്കിൽ സണ്ണ് മാറി മാറി വരുമോ?
ഒരേ സ്ഥലത്ത് അല്ല, മാറി മാറി വരും.
എങ്ങനെയാണ് മാറുന്നത് അത്?
നമ്മൾ എർത്ത് റൊട്ടേറ്റ് ചെയ്യുന്ന
അല്ല, എർത്ത് റൊട്ടേറ്റ് ചെയ്യുന്ന വിട്ട്, പക്ഷേങ്കില് സ്കൈയിൽ നോക്കിയാൽ സൺ എങ്ങനെ ഉണ്ടാവും? സണ്ണ് എവിടെയായിരിക്കും? രാവിലെ സണ്ണ് നോക്കിയാൽ എവിടെയായിരിക്കും?
ഈസ്റ്റ് സൈഡ്.
ഉച്ചക്ക് നോക്കിയാലോ?
ഉച്ചക്ക് നോക്കിക്കഴിഞ്ഞാല് കറക്റ്റ് നടുവിലുണ്ടാവും.
കറക്റ്റ് നടുവിലുണ്ടാവും. അതിന്റെ പറഞ്ഞ മേലെ ഉണ്ടാവും. ഒരു 10 മണിക്ക് നോക്കിയാൽ ഇങ്ങനത്തെ ഈ ഡയറക്ഷനിൽ ഉണ്ടാവും. 6 മണി, രാവിലെ 6 മണി നോക്കിയാൽ ഇവിടെ ആയിരിക്കും. 10 മണി, 12 മണി, റൈറ്റ്. പിന്നെ ഒരു 4 മണി, 6 മണിക്കാകുന്നപ്പോഴത്തേക്ക് പിന്നെയും അസ്തമിക്കും. അത് കഴിഞ്ഞിട്ട് ഇറ്റ് ഈസ് ഗോയിങ് ഡൗൺ ആൻഡ് കമ്മിങ് ബാക്ക് അപ്പ്. താഴെ പോയിട്ട് താഴെയിലൂടെ തന്നെ പിന്നെയും മേലെ വരുന്നുണ്ട്, റൈറ്റ്? That's a circle. Okay. ഇനി പറയാ സ്റ്റാർസ് എന്ത് ചെയ്യുന്നു?
അവിടെ തന്നെ നിൽക്കും.
സ്റ്റാർസ് എപ്പോഴും അവിടെ തന്നെയാണോ? Are the stars always static?
കറക്റ്റ് അറിയില്ല.
Aryan? സ്റ്റാർസ് മൂവ് ചെയ്യുന്നുണ്ടോ അല്ലെങ്കിൽ എല്ലാം ഒരേ സ്ഥലത്താണോ അവിടെ?
സാർ, അത് മൂവ് ചെയ്യുന്നുണ്ട്.
മൂവ് ചെയ്യുന്നുണ്ടോ? സ്റ്റാർസ് ഒരേ സ്ഥലത്താണോ മൂവ് ചെയ്യുന്നുണ്ടോ? അറിഞ്ഞൂടാ. ഓക്കെ. Joan, do you know what happens to the stars in the night? Have you ever observed? Do they move or do they stay still?
Maybe Shajesh, you can ask, which is the only star which does not move?
Yeah, that is the second question actually. Yeah. That's better. That's better. Yeah. Yeah. So basically, Uttara idana sun ingana mela varunittu ingana ponille. All stars rise from the east and then west in the set in the west. Ella starum mela varum താഴെ പോകും. അത് എന്തുകൊണ്ടാണ് ആകുന്നത്?
നമ്മൾ എർത്ത് റൊട്ടേറ്റ് ചെയ്യുന്നതിനനുസരിച്ചിട്ട് അതിങ്ങനെ നീങ്ങും.
എക്സാക്ട്ലി. അത് നമുക്ക് തോന്നുന്നതാണ് അത് അങ്ങനെ മൂവ് ചെയ്യുന്നത്. പക്ഷേ എങ്കിൽ ദേ ആർ ഓൾ സ്റ്റിൽ നമ്മളാണ് ഇങ്ങനെ റൊട്ടേറ്റ് ചെയ്യുന്നത്. അത് കാരണം എന്ത്
ഇല്യൂഷൻ മാതിരി ഇങ്ങനെ നമുക്ക് തോന്നുന്നത്.
correct exactly. Okay, so അപ്പം നമ്മളിപ്പം റൊട്ടേറ്റ് ചെയ്യുന്നുണ്ടെങ്കിൽ ഇപ്പം പ്രദീപ് told us is there anything that stays still in the sky? So if I were to draw, let us see. ഇത് നമ്മളെ എർത്ത് ആണ്, correct? അതിനൊരു this is the axis, correct? Earth is rotating about this point. Agreed? ഇപ്പം suppose നമ്മൾ ദൂരെ നോക്കുന്നുണ്ടെങ്കിൽ എല്ലാ സ്റ്റാർസും ഒരു it is like on a sphere. ഇവിടെ ഒരു star undangle it will move like this, correct? This is another star's motion. This is another star's motion. Sun ഇവിടെയാണ് ഇല്ലത്, നമ്മൾ ഇക്വേറ്ററിന്റെ മേലെയാണ് sun ഇല്ലത്. But some stars are in this point also. But what will happen if there is a star here? നമ്മളൊരു സ്ഫിയറിൽ റൊട്ടേറ്റ് ചെയ്താൽ ഇഫ് യു ആർ ഓൺ നോർത്ത് പോൾ റൊട്ടേറ്റ് ചെയ്യുക. ഈ പോയിന്റ് ഏറ്റവും മേലെ എർത്തിന്റെ ഏറ്റവും മേലത്തെ പോയിന്റാണ് നോർത്ത് പോൾ എന്ന് പറയുന്നത്. അവിടുന്ന് നമ്മൾ എക്സ്റ്റെൻഡ് ചെയ്താൽ ഈ പോയിന്റ് ഉണ്ടാവും, അത് റൊട്ടേറ്റ് ചെയ്യൂല. This point will stay the same. So നമ്മൾ സ്കൈയിൽ പോയിട്ട് ഒബ്സർവ് ചെയ്തിട്ട് എല്ലാ ദിവസവും നോക്കിയാൽ ഇവിടുന്ന് സ്റ്റാർ റൈസ് ചെയ്യും, അപ്പുറത്ത് പോയിട്ട് സെറ്റ് ചെയ്യും. കുറെ സമയം എടുക്കും. 6 മണി അല്ലെങ്കിൽ 7 മണി രാത്രിക്ക് റൈസ് ചെയ്യും, പിന്നെ ഒരു 6 മണി രാവിലെ സെറ്റ് ചെയ്യും. പക്ഷെ ആ സമയത്തെല്ലാം ഈ സ്റ്റാർ എപ്പോഴും സ്റ്റാറ്റിക് ആയിരിക്കും, അവിടെ സ്റ്റിൽ ആയിട്ട് നിൽക്കും. ഓക്കെ, അപ്പൊ നെക്സ്റ്റ് ഒബ്സർവേഷൻ ചെയ്യേണ്ടതെന്ന് പറഞ്ഞാൽ അടുത്ത പ്രാവശ്യം സ്കൈയിൽ നോക്കുമ്പം ഈ പോയിന്റിനെ ശ്രദ്ധിക്കണോ. എല്ലാ സ്റ്റാർസും ഒരു പോയിന്റിന്റെ ചുറ്റുമാണ് പോകുന്നത്. ദാറ്റ് ഈസ് ദ നോർത്ത് സ്റ്റാർ. നമ്മളെ ഇവിടെ ഈ നാട്ടില് കുറെ മരങ്ങളില്ലോണ്ട് നോർത്ത് സ്റ്റാർ കാണാൻ കുറച്ച് വിഷമാണ്. ബിക്കോസ് നമ്മൾ ഇക്വേറ്ററിന്റെ അടുത്താണ് 10 ഡിഗ്രി 11 അല്ലെങ്കിൽ 10 15 ഡിഗ്രീന്റെ ഉള്ളിലായിരിക്കും ഇത് ഉണ്ടാകുന്നത്. അതിന്റെ അർത്ഥം 10 15 എന്ന് പറഞ്ഞാൽ ഇത് 0 ഡിഗ്രി. ഇപ്പൊ ഡിഗ്രി എങ്ങനെയാണ് മെഷർ ചെയ്യുക, ആംഗിൾസ് മെഷർ ചെയ്യുക എന്ന് പറഞ്ഞാല് ആദ്യം കൈ വെക്കാം. സോ ദിസ് ഇസ് എ വേ ടു മെഷർ ആംഗിൾസ്, റൈറ്റ്? ഇത് 0, അത് 10 ഡിഗ്രിയാണ്. ഇത് 20, right? This is 30, right? 40, 50, 60, 70, 80, 90. Okay. Upon every star na nammalippam varum oru angle ee protractor onnu illande nammal oru angle il vechittu nokka etra angle undu ennu nokka. Correct? So main idea is all stars rise in the east and set in the west, including the sun. Is sun a star?
Yes.
Very good. Very good. That is the closest star. That is our star. നമ്മൾ അതിന്റെ ചുറ്റും പോകുന്നത് അതുമായി തന്നെ ഒരു കുറേ stars ഉണ്ട്. Most of the stars are very, very far away. Okay. Moon is very close to us. Okay. Moon, does the moon rise and set?
Yes.
That is correct. Very good. Like everything in the sky, moon also rises and sets. But moon, why does it look? Sometimes it is big, sometimes it is half, sometimes a crescent shape, or a C. Why does it do that?
എനിക്ക് തോന്നുന്നത് എർത്തിന്റെ റിഫ്ലക്ഷൻ ആണെന്ന്.
എർത്തിന്റെ റിഫ്ലക്ഷൻ റീസണബിൾ, പക്ഷേങ്കിൽ അത്ര റിഫ്ലക്ട് ചെയ്താലും മൂൺ ഒരു കുറെ ദൂരെയാണ്. അത് കാരണം റിഫ്ലക്ട് ചെയ്താലും അതിന്റെ അടുത്ത് വരെ എത്തൂല. പക്ഷേങ്കിൽ സണ്ണ് സ്കൈലുണ്ടല്ലോ, അതുകൊണ്ട് സണ്ണ് ഷൈൻ ചെയ്യുന്നതാണ് അതിന്റെ ഫലം. സോ ലെറ്റ് us try to understand that. Okay, so I'll try to explain this. So ഇത് നമ്മളെ എർത്ത് ആണ്. Okay, and ഇവിടെ സൺ ആണ്. സൺ is very big. So sun ഇവിടെയാണ്. Right, this is sun. എർത്തിന്റെ റിലേറ്റീവ്ലി എത്രയോ വലുതാണ്. So it is very huge. സണ്ണിന്റെ ലൈറ്റ് ഇവിടെ നിന്നെല്ലാം ഇങ്ങനെ വരും. ലൈറ്റില് ഒരു ലൈറ്റിന്റെ മുമ്പിൽ നമ്മൾ നിന്നാല് we get front side is bright, back side is dark. Correct? അപ്പം എർത്തിന്റെ ഇത് bright ആണ്, so that is white, and this is black. അതാദ്യ color black ആണ്, so I don't have to shade it. So this is bright side. White chalk കൊണ്ട് ചെയ്തത് white ആണ്. അവിടെ സണ്ണ് വരുന്നുണ്ട്. റൈറ്റ്, മൂന്ന് സണ്ണ് എർത്തിന്റെ ചുറ്റും പോകുന്നതാണ്. മൂൺ ഈസ് എ സാറ്റലൈറ്റ് ഓഫ് എർത്ത്. എർത്തിന്റെ ചുറ്റും ഇങ്ങനെ പോയിക്കൊണ്ടിരിക്കും. എർത്ത് സണ്ണിന്റെ ചുറ്റും പോകുന്നതാണ്. ഓക്കെ, ആൻഡ് സൺ ഗാലക്സിയില് ഒരു വലിയ സ്റ്റാറിന്റെ ചുറ്റും പോകുന്നതാണ്. A cluster of stars in the chuttum പോകുന്നതാണ്. Correct? Again, moon goes around the earth, earth goes around the sun, sun goes around a cluster of stars or a black hole in the galaxy. നമ്മളെ ഗാലക്സിന്റെ പേരെന്താണ്?
മിൽക്കി വേ.
Very good. നമ്മളെ ഗാലക്സിന്റെ പേര് മിൽക്കി വേ. റൈറ്റ്? അത് ആക്ച്വലി മിൽക്കി വേ സ്കൈല് നോക്കിയാൽ ഒരു എത്രയോ, ഇഫ് ഇറ്റ്സ് എ വെരി ഡാർക്ക് സ്കൈ, നമുക്കത് കാണാൻ പറ്റും. നമുക്ക് നമ്മളെ തന്നെ ഗാലക്സി കാണാൻ പറ്റും. ഇറ്റ് വിൽ ബി ലൈക്ക് എ സ്ട്രെച്ച് ഓഫ് വൈറ്റ്, ഇറ്റ് വിൽ ബി ലൈക്ക് എ റിവർ, അങ്ങനെയാണ് പറയുന്നത്. അതുകൊണ്ടാണ് മിൽക്കി വേ എന്ന് പറയുന്നത്. പക്ഷെ വെൻ യു ലുക്ക് ഇൻ ദ സ്കൈ, ഒരു പാച്ച് ഓഫ് വൈറ്റ് ലൈറ്റ് മാറിയിട്ടുണ്ടാവും. It will be ഒരു പാച്ചിൽ മാത്രം ഒരു ബ്രൈറ്റ് ആയിട്ട് ഒരു വെരി ഷെയ്ഡി വൈറ്റ് ആയിട്ടുണ്ടാവും. സോ ദാറ്റ്സ് വൺ വേ. പക്ഷെ ഇറ്റ് ഈസ് യൂഷ്വലി ഞാൻ കണ്ടതിൽ തലശ്ശേരി അത്രയൊന്നും ഈസി ആയിട്ട് കാണില്ല. പക്ഷെ കുറെ ദൂരെ ഉള്ളിലോട്ട് എവിടെയെങ്കിലും പോയിട്ടുണ്ടെങ്കിൽ വേർ ഇറ്റ് ഈസ് വെരി ഡാർക്ക്, ലൈറ്റ് ഒന്നും ഇല്ലാത്ത സ്ഥലത്ത് there is a chance you might see it. Okay, so that's ipo namma moon idinte chuttum poleയാണ്, right? That's the moon's orbit. Okay, so let's keep the moon here. So that is moon. Okay, that is earth, but the moon on moon also is not having light of its own. The sun inde light inde valeyana depend cheyyunnathu. So ippam ivada sun undengil, when the moon is here, this is bright and inganeyana kana, correct? Pakshengil, now notice what happens. Let me get a small sheet of paper. Even though the moon is shining this much, idinte paadi bhagam namakku kaanula. If we are standing here, namakku moon inde itra bhage kaanum, correct? Because the back side we cannot see. Okay, so moon looks only this much. Appo itra maatrame namakku kaanum. Agreed? So namakku half moon aanu kaana. Ee moon ivide illa sthalathu. Is that clear? Now suppose I put the moon here. Moon move cheyidittu ivada vannu. Still the sun is going to brighten it like this. Pakshengile, now we can see only this much of the moon. Correct? Appo namakku idu oru crescent aayitana kaana. We can see only this much. പക്ഷേ അതൊരു 3-dimensional ആയിട്ട് നോക്കിയാൽ it will be a crescent. Okay, so this is a crescent. I think the spelling is correct. This is half moon. Okay, and what happens if you are here? നമ്മളിപ്പോ രാത്രിയും പകലും നോക്കുന്നില്ല. Remember that sun moves around also, or I should say earth moves around the sun also. Adu karana sun inde position can change from here to there. Nammalippum varu avada oru sthalathu vechittu parayunnanu, പക്ഷേ this can itself move on its own. ഇവിടെയാണെങ്കിൽ this gets brightened up like this. Okay, and again ipo njan idu shade namakku earth inde half aite kaanu. Ipo idu endana kaana, namakku moon kaanumo? എന്താണ് കാണാൻ നമുക്ക്? ഒന്നും കാണൂല, because this is dark, right? There is no light falling on it, so we will see no moon. So this is a new moon. ഇതിൽ no moon ആണ്, so it is often called new moon day, right? So there is no moon on that particular. Again, this can be stretched. Same argument pinning bone. Right, this time again shade this here. E prasham ipparthote kaanam. See, notice the difference between these two. E crescent angotekana thiriyunnathu, e crescent ingotekana thiriyunnathu. So based on the shape of the crescent, നമുക്ക് പറയാൻ പറ്റും മാസത്തിന്റെ ഏത് ദിവസമാണ് നടന്നുകൊണ്ടിരിക്കുന്നത്. If suppose you get lost, you don't have a phone, you don't have a calendar, എവിടെയും സമയം നോക്കാൻ പറ്റുന്നില്ല, ഡേറ്റും നോക്കാൻ പറ്റുന്നില്ല, അപ്പൊ നമുക്ക് മൂന്ന് നോക്കിയിട്ട് നമുക്ക് അറിയാൻ പറ്റും എന്താണ് ഏതാണ് ഡേറ്റ് എന്ന്, if we follow it carefully enough. ഈ മൂന്ന് ഇവിടുന്ന് പോയിട്ട് ഫുൾ ഇങ്ങോട്ട് വരുന്ന എത്ര ദിവസമാണ് നടക്കുന്നത്? How many days does the moon take to go around or go around the earth nalla parayande? So basically ee no moon day nu ivada full moon day and പിന്നെയും new moon day വരാൻ എത്ര ദിവസമാണ് എടുക്കുന്നത്? How much? Tell that again. ഒരു ദിവസമല്ല, ഒരു ദിവസം ആക്ച്വലി സൺ ഈ റൈസിങ് ആൻഡ് സെറ്റിംഗ് ആണ്, അത് നമ്മൾ എർത്ത് റൊട്ടേറ്റ് ചെയ്യുന്നതാണ്. പക്ഷെ ഞാൻ പറയുന്ന ഈ മൂണിന്റെ സൈക്കിൾ ഉണ്ട്, ഈ ഫേസസ് ഓഫ് മൂൺ എന്ന് പറഞ്ഞാൽ ഒരു ദിവസം നമ്മൾ ഹാഫ് മൂൺ ആയിട്ട് കാണുന്നു, അടുത്ത ദിവസം അതിന്റെ ഷേപ്പ് മാറി, നെക്സ്റ്റ് ഡേ അഗെയിൻ ദ ഷേപ്പ് ചേഞ്ചസ് ഫ്രം ഹിയർ ടു ഹിയർ. Very good, that is correct. 7 days, that is the 7 days of a week, right? 7 days of a week വരുന്നത് അതുകൊണ്ടാണ്. ഒരു വീക്കില് ഇവിടുന്ന് ഇവിടെ എത്തി, രണ്ടാമത്തെ വീക്കിൽ ഇവിടുന്ന് ഇവിടെ എത്തി. So 14 days. This is 21 days. And then it is 28 days. ഇത് full circle ഒരു ദിവസം നമ്മൾ add ചെയ്യണം because the moon itself is moving around. So it is 28 to 29 days എന്നാണ് പറയേണ്ടത്. So there are other features that come in. പക്ഷേ broadly നമ്മൾ പറഞ്ഞാൽ 28 days ആണ് എടുക്കുന്നത്. So every week ഇത് half moon no moon ആയി, ഇവിടുന്ന് പിന്നെയും half moon ആയി, പിന്നെ half moon full moon ആയി. Let me draw this completely. So this is ഇവിടെ ഉണ്ടാവുമ്പോൾ ഇവിടെ നമ്മൾ കവർ ചെയ്താൽ this is a full moon day, right? So this is, oops, did I get switched off?
No, you're back.
Okay, I accidentally tripped on the wire.
Your video is gone.
Yeah, I think it is resetting itself. Give it a minute, I think it will be okay. Okay, is it better? Or
You're back.
I should be back now, right?
You're back. You're back.
Okay, nice. Okay, so I think I switched off my light also. Yeah, okay. So here, this is a full moon. Okay, and this was again half moon. So no moon, half moon, full moon, and again the crescents change shape. This is called a crescent, and this one, see, notice what is happening. This is more than half. Like these two were crescents. Either more than half on. So this is often called gibbous. That's a name attached to that. And here the crescent is getting smaller. This is called a waning crescent. Waning or crescent ഈ മൂന്ന് ചെറുതായിക്കൊണ്ട് നിൽക്കുന്നതാണ്. ഇവിടെ മൂന്ന് വലുതായിക്കൊണ്ട് നിൽക്കുന്നതാണ്. So that is called waxing. ഇവിടെ മൂന്ന് വലുതായിക്കൊണ്ട് നിൽക്കുന്നു, ഇത് ചെറുതായിക്കൊണ്ട് നിൽക്കുന്നു, and ഇവിടുന്ന് അങ്ങോട്ട് പോകുമ്പോൾ this is getting bigger gibbons, so that is waxing gibbons, and this will be waning gibbons. So that's your half moon and full moon. Next thing moonine pattite അറിയേണ്ടത്, if you see the moon, ipa moon ingana karangunnundengil, is the moon rotating at all? Earth is rotating about the axis, correct? Is the moon rotating about the axis?
Yes.
And if it is rotating about the axis, that is correct. That moon is rotating about the axis. Appam, if suppose Adish is rotating about his axis and I am looking at Adish, appo enakku Adishinte back side um front side um kaanan pattilla. Correct? Appo namakku mooninte back side um front side um kaanan patto? Usually it is called far side and near side. So that is a tricky question. So suppose this is Earth, right? And this is again moon in the orbit. Now imagine this is the moon and this is the, let me call it the dark side, right? This is dark side. This is the front side. Okay, near side. Let me call that near side. So this is, no, it is not called the dark side. It is called far side, right? So this is called the far side. And this is the near side. Okay. Now the point is, if you look at the moon, in the moon പോയിട്ട് നോക്ക, പുറത്തു പോകുന്ന സമയത്ത് moon നോക്ക, നാളെ പോയിട്ട് moon നോക്ക, does the pattern in the moon change? Moon ന്റെ മേലെ ഒരു pattern കാണും. Correct? അതില് even though it is white, ശ്രദ്ധിച്ചു നോക്കിയാൽ അവിടെ ഒരു ഷെയ്ഡ്സ് ഉണ്ട്, കുറച്ച് ചില സ്ഥലത്ത് ബ്ലാക്ക് ഉണ്ട്, ഒരു ഷെയ്ഡ് ഉണ്ട് അതിന്റെ മേലെ. ആ ഷെയ്ഡ്സ് മാറുന്നുണ്ടോ ഇല്ലേന്ന് ശ്രദ്ധിക്കുക. Is the pattern on the moon changing or not? ഇത് റൊട്ടേറ്റ് ചെയ്യുന്നുണ്ടെങ്കിൽ the face of the moon should change. Correct? പക്ഷേ if you observe, we are always seeing the moon on the same side. ഇത് ഇവിടെ നിൽക്കുമ്പം same side ആണ് കാണുന്നത്. So let me call it 1, 2, 3, 4. നമ്മൾ കാണുന്നത് 3 ആണ്. Correct? ഇത് ഇവിടെ എത്തുമ്പം this is still 3, this is 4, this is 2, that's 1. നമ്മൾ കാണുന്ന ഏത് സൈഡാണ്? 3. ഇവിടെ പോയാൽ again it is 3, 4, 1, 2. 3 is closer to Earth. Is the moon rotating?
Yes.
Yes, moon is rotating because otherwise, if it is not rotating, 3 will be at the bottom, right? So moon is rotating, but the moon is rotating in such a way, very special, that by the time Earth rotates one rotation, moon also makes exactly one rotation. Exact lock ana nammale rotationum mooninte rotationum, it is completely locked. Okay, aa locking nu kore samayam edukkum. So that means that earthum moonum kore kaalathekku orumichayirunnu. If ഒരു പുതായിട്ട് moon ആണെങ്കിൽ, so they will not be locked, so they will be having different rotations. കുറേ നേരം ഒരുമിച്ച് നിന്നാൽ they both understand each other and then they get locked. That is called tidal locking. So there is a meaning for the word tidal, but we won't go into the details of that. Okay, so I will stick only to this much. So what we have done today is we have said moons have phases. Sometimes they are crescents, sometimes they are gibbous, full moon, new moon, and they are periodic in 28 days. Okay. And that is why our weeks have 7 days in a week. And months have about 28 days. What is a lunar calendar and what is a solar calendar?
Nothing.
Calendar is basically using some periodicity around us. Periodicity means something that is happening again and again. Right? Nammala sky sun ella divasam varunundu. That is periodic. Periodic nu parnja pinniyum sambhovikkunnu. Every 24 hours sun comes in the sky. Right? That's periodic. Every 28 days the moon disappears. That's periodic. Right? If a moon in the period vechittu cheydale, then it is called a lunar calendar. Sun in the period vechittu cheydale, it's called a solar calendar. Okay, both calendars are useful, and in our we use both lunar and solar calendar. How about that? That's an easier way to say. Okay. Any questions? Anything at all? Nothing at all?
I have a question.
Yes, please. Yeah.
Hey, I was under the, and I think this the rotation of the moon and the revolution of the moon are actually the same. It's 28.5 days. And that's why you don't see the far side of the moon, what I was thinking. So the time it takes to revolve is the same time that it takes to rotate.
That's correct. Did I say 24 hours earlier? Probably.
You said you sort of, you mentioned that the earth rotates, and that same rotation is this. The earth rotates in 24 hours, right? But the moon rotates in 28 it takes 28 days.
That's
28 and a half days. Yeah.
That's correct. That's correct. So what is the sinking then, right? Hold on.
I think it is because it doesn't, it moves only, what you said, tidal lock is important.
Yeah. I think the main point is that it is always facing that. And yeah, so it has nothing to do with the, it doesn't mean that the rotation frequency is fixed. It is just that once when it goes around.
Yeah, when it goes around, it also revolves.
Correct, exactly. The rotation around its axis is exactly equal to revolution around its axis. I think that is the law.
That is why it is tidally low.
Yes.
Means it must have been it is fixed.
Correct. Yeah. I said it wrongly. Yeah. Very good point. Yeah, that clarifies. Yeah. Thank you. Yeah. That's a good clarification. Yeah. Good point. Anything else you should add, Pradeep? Can you think of adding something to this?
Yeah, I always wondered how the ancients calculated eclipses so correctly, and because in those that means it is not on one plane, right? They knew that the moon is not on the fixed plane. It also
I'm not sure how accurately they must have predicted it. Because like again, it depends on how ancient do you go. If you are in the last 2000 years, yes, they.
Yeah. I'm talking about 2000 years, 2 million. I'm not talking about 5 million or something.
Yeah. 2000 years they were good. Remember, 2000 years back you had trigonometry, right? So then you could really do many calculations because trigonometry helps to get all these angles cleared. Even 3000, I would say to a certain extent, yes, but they're predictive. prediction may not be accurate enough.
Mm-hmm.
But many of the, like, because they had all this, what is this called? What's the word for this? Where they used solar times, where they make the structure and the shadows give you the time.
Okay.
So those instruments could help them a lot.
To check whether the sun and the moon are on the same plane, right? On the same same axis. Yeah.
Yes. So I would say yes, maybe to a great extent, even eclipses they might be able to predict in that way, in that manner.
There are reports of even when Alexander came to India, eclipses being predicted.
Yeah, but that is again 300, like 100 BC.
Yeah, 2300.
Yeah. So that surely at that time, because Ptolemy's work is pretty extensive and they could do a lot of stuff. But probably 3000 years, it might have been limited. We have astronomy way back in 4000, 5000 years. That is true. But whether they could predict eclipse or not, I'm not sure. Maybe yes, because they just have to follow two circles, right? Following two circles may not be that hard, especially if you have these instruments, because they did come up with all these instruments at that time.
But you have to measure that, right? You need to know for sure that on this particular day, and that the earth and the sun and the moon will be on the same plane. Yeah.
So not sure actually. That's why I'm doubting it, but then I'm not very sure about it. But at the same time, I also know that since it is just two circles, you can use geometry, right? Without any calculation.
I was watching one National Geographic one, one about one shipwreck near Greece. And it seems that it had come from Egypt. And they had that one instrument, which sort of, it's an analog sort of computer-like thing, which looked at the planets moving around the sun. And with that, they could predict eclipses.
Correct. I wouldn't be surprised because eclipse again is only two orbits, right? Sun and moon. It might be possible, yeah. But what was, I do know the following, like this was a big deal. So this is a nice story that sometimes planets go through the face of the sun. That's called a transit. For example, especially Venus and Mercury go in front of the sun. And by 1500 and 1600, they were very good at these calculations. But even then, they made mistakes of 1 hour.
Okay.
So it was a big embarrassment at that time that, okay, you bring in a huge set of people, like thousands of people, or even if it is a royal family of about 100 to 500 people, and then you're waiting for it, and it doesn't show up, right? So it used to happen with Mercury especially. They did not know why Mercury was behaving differently for a long time, until about 1900, they didn't know that.
Till Einstein has to come in.
Yeah, correct, exactly. And in between, but they did find the corrections to it, but yeah, they were not knowing what it is exactly. Yeah. So what I'm trying to say is that even at that time, they were making errors, right? So
correct.
So in that sense, it is, 1 or 2 hours surely. So it is not sure. For example, you have this stories like Mahabharata, where an eclipse plays a very important event. So did they know about it so precisely that you can create a story around it? I'm not sure.
Yeah, that is that this one that what's that, killing of the
exactly
elephant, right? Ashwatthama.
Yeah, that was my point. I was keeping in mind, but you really need to know that for very precisely, right? Within 5 minutes or so.
Yeah.
So not sure if those accurate predictions were possible or not, but that's a good thought.
Yeah, but probably you can predict where the sun is and where is the where the moon rises, every day you plot it, probably you can know for sure where it will be, right?
Probably. Yeah. Agree. Yeah.
Yeah, because does the moon have a play of more than 23.5 degrees?
Does moon have what?
So the sun because of the Earth's tilt, right? It goes up to 23.5 degrees north and 23.5 degrees south, right?
Right.
So that is so we say that is the rise of the sun in the northern hemisphere. You will see from December onwards it will move up, correct? And up to June, it'll come all the way to 23.5 degrees. But the moon probably is more closer, so its precision is it's not on a fixed plane, right? So it may not be going far away. And
your point is that are these in the same plane or not? Again, to the best of my knowledge, they are all in the same plane. It is almost like most of the solar system is in the same plane.
Yeah, that's because this is that is because this sun is going around the galaxy, right? And it is moving, and the sun is traveling, is it is revolving around the center of your galaxy, right? It means around the center, and every planet is following it, right?
That probably plays a role, but the more interesting thing is that they all started from the same dust.
Yeah, but dust can be different. No, one can be dust will be on one side and one.
But they all will, after the spin, they will all come together. If they are not, that means they came and hit the solar system later stage. Unless it's a foreign body, most of them will be in the plane apparently. Again, this can be cushioned probably, but it's like, for example, Neptune, I think has its it's
got a 90-degree tilt, right?
Exactly,
something like that.
Exactly. And this is a typical argument, but I don't think this is conclusive. This is not very well established. But it is true that angular momentum conservation will make everything in a flat plane. And then you're trying to suggest that, oh, what if something is on the top?
But then it might be overall on the same plane, but maybe 1 or 2 degrees separate. But 1 or 2 degrees with respect to Pluto will be huge compared to what will be with Mercury. Exactly. So it will be a huge difference. So almost on the same plane, but still it might be having huge astronomically when you look at it. The distances might be too wide, especially if you're going billions of kilometers.
I think it might be true. Again, I haven't derived this or done any of this. Suppose you have a huge spherical dust ball and they all have random velocities and you keep gravity, each one can attract the other. So then slowly they will start spinning around in all directions. And it might be true that they will come and form a disk if you give it enough time. Probably.
You have spherical balls, is it?
So you're saying there is a spherical dust, but each dust particle can attract another one.
Yeah, that's true.
They all have initial directions different.
But Shajesh, the point is 99% of your mass of the solar system is in the sun.
Correct.
99%, right? Yeah, or more than that. Almost 99. It's only some very infinitely small mass which is following
million, like beyond the 7th digit.
Yes, so that.
But I'm just saying, even before that. When that whole thing was coming together, like even the star formation, everything. Apparently, when it collects, eventually it will form a disk. Probably, again, one should.
Why disk? Why not a 3D object?
Again, I'm just intuitively thinking, like, suppose you have, let's take 2, okay? Just 2 of them. They have, let me try to draw this. Maybe.
Be careful of your time. You will need to go to sleep. So. Yeah.
No, I think you should.
Because I am all with the full dopamine with sun shining out. That sure.
Okay. So let's say you have just two objects. Okay. So that is this going randomly in this direction and this one going randomly in that direction, right? That's two random objects, but there is gravity acting inward, right? So there is a force on this and there is a force on this. But there is this initial conditions which is all weird. So if I keep this as fixed, then basically it will start coming towards it, but then there is a motion because of the velocity. At least when there is only two, you can think of it as going in a circle, right? For sure.
Right.
So I've got one so this is fixed now, let's say. That's my reference frame. Now let's say I have another one also randomly going in different direction. That's this. This will also try to go around this, the component of this, like this component will not get affected. This component will try to make it move in a circle in this manner. But this is also pulling it, remember? Right. So overall, yeah, I cannot prove it as such, but my claim is that overall they will be very well comfortable only when they are in a disk. They'll keep going around, but eventually gravity will pull them into a disk.
But sorry, somebody was saying something.
Any comments? I think that was.
Yeah, but if everything is formed from the same dust accretion, right? What's the accretion, right?
Yeah.
Then if it is from the same, then already probably they are already in the same.
If they're all going already in the same, then it's a different scenario. Yeah, but most of the time that's not the way it is, right? They all initial condition is they're all randomly going and suddenly or gravity gets dominant when they are closer, let's say.
Closer to each other.
Right.
One of those lectures of Feynman, he was showing about the this one, and he shows the same analogy, but he shows it as some data from galaxies. There is in the Milky Way neighborhood galaxy, which is called, there's a cluster of galaxies which are very, very close to each other. And then there is a vast path. So he says that probably over that's what he shows the same vectors. And because each of them have formed independently, but they are, what's it called? We are in a part of a galaxy cluster, which very close to each other, if I understood it correctly.
Possible, yeah. I don't know the name. Yeah, I don't know.
And he used the same vectors to show that over time, all of them will be close, and that makes sense because of gravitational forces.
Yeah.
But there are other galaxies which are again forming patches, because this same dot could be the size of a galaxy also in the scale of universe, right?
Yeah. But I'm not able to make this concrete. I mean, it will be good if I can make an argument that eventually they will come to a disk. But yeah, I don't think I can right away say anything on that. But there must, I mean, it might be possible to make such an argument. So I'll think about that.
Yeah, because in this case, the sun is moving, and sun is moving it's moving on the center of the galaxy. And around the sun, this small was 1% masses at different distances, moving along.
Moving along.
Exactly. Moving along, right? But moon is slightly different. Moon has got a wider, this one than, I think, angle, if I understood, angle than more than 23.5 degrees.
Possible.
So you have to calculate that.
Yeah. I haven't. Yeah. This is very,
Yeah.
remember that. I mean, mainly I started talking about astronomy thinking because there were about 5 students interested in astronomy, but none of them came today. So that's very ironical. Yeah.
Okay.
So maybe
Okay.
my old lectures were more popular. They're more
Yeah.
interesting.
Oh no, maybe they must have gone for holiday.
Yeah, that's also possible. Yeah.
Yeah. Okay. Good.
Okay. So good. Yeah.
Okay.
Thanks, Pradeep. Yeah, this discussions help. Yeah.
Good night.
Okay.
Take care.
Okay. Bye-bye. Bye, guys. Bye, Joan. Bye, Adish. Yeah. Okay. I'll close. Adish, any questions?
No, sir.
No? Okay. Okay. Bye to Aryan also. Yeah. Bye. Yeah. Okay. Seri, Ashwati. Yeah.